A servomotor is an electromechanical device that is used in a wide range of applications, from robotics and automation to aerospace and defense. It is a type of motor that is designed to provide precise control over its rotation, speed, and position. In this article, we will provide a detailed overview of servomotors, including their operation, characteristics, applications, and advantages. Operation of a servomotor. A servomotor operates on the principle of closed-loop control, which means that it receives feedback signals from a sensor and adjusts its motion accordingly. The sensor, typically an encoder or a potentiometer, measures the position or speed of the motor shaft and sends a signal to the servomotor controller. The controller processes this signal and adjusts the voltage or current supplied to the motor windings to maintain the desired position or speed. The servomotor has a built-in gear train that reduces the rotational speed and increases the torque output. This allows the motor to drive a load with high precision and accuracy, even at low speeds. The servomotor is controlled by a pulse width modulation (PWM) signal, which is a digital signal that varies the duty cycle, ratio of on-time to off-time, of the signal. The PWM signal is usually generated by a microcontroller or a dedicated servomotor controller, such as a servo drive. The PWM signal is fed to the servomotor controller, which amplifies the signal and sends it to the motor windings. The motor rotates until the feedback signal from the sensor matches the desired position or speed. The servomotor controller continuously adjusts the PWM signal to maintain the desired position or speed. Characteristics of a servomotor. Servomotors have several characteristics that make them suitable for precision control applications. High precision and accuracy. Servomotors are capable of precise and accurate motion control due to their closed-loop control system. They can maintain a constant position or speed with high repeatability and accuracy. High torque and low speed. Servomotors have a high torque output at low speeds, which makes them ideal for applications that require high force but low speed. The gear train in the servomotor provides mechanical advantage, allowing the motor to generate high torque even at low speeds. Fast response time. Servomotors have a fast response time, which means they can quickly adjust their motion to match the desired position or speed. This is important in applications that require rapid changes in motion, such as robotics and automation. Low vibration and noise. Servomotors operate smoothly and quietly due to their precise control system and gear train. This makes them suitable for applications that require low noise and vibration, such as medical equipment and laboratory instruments. High efficiency. Servomotors are highly efficient, which means they can convert electrical energy into mechanical energy with minimal loss. This is important in applications that require low power consumption, such as battery-powered devices and portable equipment. Applications of servomotors. Servomotors are used in a wide range of applications, including robotics and automation. Servomotors are commonly used in robotics and automation to control the motion of robot arms, grippers, and other components. They provide high precision and accuracy, fast response time, and low vibration and noise, making them ideal for these applications. Aerospace and defense. Servomotors are used in aircraft and military equipment for precision control of flight surfaces, weapons systems, and other components. They provide high reliability, durability, and performance in harsh environments. Medical equipment. Servomotors are used in medical equipment, such as MRI machines, surgical robots, and infusion pumps, for precise control of motion and position. They provide low noise and vibration, high efficiency, and long life. Industrial machinery. Servo motors are used in industrial machinery, such as CNC machines, printing presses. Advantages and disadvantages. Advantages of servo motors. High precision and accuracy. Servo motors are designed to provide precise control over the rotation, speed, and position of the motor. They can maintain a constant position or speed with high repeatability and accuracy. Fast response time. Servo motors have a fast response time, which means they can quickly adjust their motion to match the desired position or speed. This is important in applications that require rapid changes in motion. High torque and low speed. Servo motors have a high torque output at low speeds, which makes them ideal for applications that require high force but low speed. Low vibration and noise. Servo motors operate smoothly and quietly due to their precise control system and gear train. This makes them suitable for applications that require low noise and vibration. High efficiency. Servo motors are highly efficient, which means they can convert electrical energy into mechanical energy with minimal loss. This is important in applications that require low power consumption. Disadvantages of servo motors. High cost. Servo motors are more expensive than other types of motors due to their advanced control system and gear train. Complexity. Servo motors require a complex control system that includes a microcontroller or dedicated servo motor controller, encoder or potentiometer, and PWM signal generator. Maintenance. Servo motors require regular maintenance, including cleaning, lubrication, and calibration of the feedback sensor. Limited speed range. Servo motors have a limited speed range, typically between 1000 and 5000 APM. This makes them unsuitable for applications that require high speeds. Limited torque range. Servo motors have a limited torque range, typically between 1 and 100 Newton meters. This makes them unsuitable for applications that require very high torque output. Overall, the advantages of servo motors outweigh the disadvantages in applications that require precise and accurate control over motion, such as robotics, automation, aerospace, and medical equipment. However, for simpler applications that do not require high precision and accuracy, other types of motors may be more suitable due to their lower cost and simpler design. Uses of servo motor. Servo motors are used in a wide range of applications where precise control over motion, position, and speed is required. Some common uses of servo motors include robotics. Servo motors are commonly used in robotic arms, grippers, and other robotic systems that require precise control over motion and position. CNC machines. Servo motors are used in computer numerical control, CNC, machines, such as milling machines, lathes, and laser cutters, to precisely control the cutting tool and workpiece. Aerospace and defense. Servo motors are used in aerospace and defense applications, such as unmanned aerial vehicles, UAVs, missile guidance systems, and satellite positioning systems. Industrial automation. Servo motors are used in industrial automation applications, such as conveyor systems, packaging machinery, and assembly lines, to precisely control the movement of materials and products. Medical equipment. Servo motors are used in medical equipment, such as surgical robots, prosthetics, and diagnostic machines, to precisely control the movement and position of tools and instruments. Automotive. Servo motors are used in automotive applications, such as power steering systems, throttle control, and brake systems, to precisely control the movement and position of mechanical components. Camera and video equipment. Servo motors are used in camera and video equipment, such as pan-tilt zoom, PTZ, cameras, gimbals, and drones, to precisely control the movement and position of the camera. Overall, servo motors are widely used in industries that require precise and accurate control over motion and position.